So just like last time, I'm going to do primarily screen sharing as I go through the notes so that we can kind of write them together. But the big idea for your homework, that video that you watched on X-Intercepts, was that if I have a function for a polynomial, however long or short it is, those sort of chunks in parentheses give me a clue or are related to my x-intercepts in those functions. So where you had an x-intercept at -2, you saw a piece of your function that said x plus 2 in parentheses. Where you had an x-intercept at 1, you saw an x minus 1 in parentheses. Where you had an x-intercept at 4, you had an x minus 4 in parentheses. So there's a relationship here between the function and the x-intercepts when I have my function in this format, okay? And then you looked at, if I know the x-intercepts, how we can sort of use this relationship and work backwards to go from the x-intercepts to the function. So we're going to work on page 21 today and just practice this. So same idea, we're just going to practice this relationship. So on page 21, these problems look just like the end of your notes problems from last time. On page 21, it gives us our lead coefficient and our x-intercepts for our polynomial function. Every polynomial that we're going to write for today is going to have this sort of basic form that we're just going to plug stuff into. So we'll use, if you want to use y instead of f of x, that's fine. I don't care. It's up to you. But we'll have f of x or y equals whatever our lead coefficient is. So this is the placeholder for our lead coefficient. And then x minus some x-intercept, and then x minus another x-intercept as many times as we need to for our different x-intercepts. So these are all going to be our x-intercepts. Okay, so that's the format that we're going to use here. So for number 1, we have our lead coefficient and our x-intercepts. So I'm just going to plug that information into my sort of generic form that I have here. So I'm going to start off with f of x equals, again, if you want y equals, that's fine too, it means the same thing. My lead coefficient is -3, so I'm going to put that in front, sort of like the line leader for my function. And then x minus -1, x minus 0, and x minus 1 is our last x-intercept there, okay? I'm using minus signs in here because if you notice from our notes problem, these signs were opposite our x-intercept values. And so if I default to subtraction, those signs will work themselves out the way that they're supposed to be. Okay. Now, I can clean this up a little bit, so I want to make sure that I do that. So here where I've got minus -1, minus a negative, I can write as positive. So I can write that as x plus 1. And then where we have x minus 0, you saw this in one of your notes examples from your homework, I can actually just write that as x. If you want to keep it in the middle, that's fine. If you want to throw it in front next to the -3, that's fine too. But we have a cleaned up version of this that looks like this. F of x equals -3 times x plus 1 times x minus 1. And any order on, the lead coefficient needs to be in front, but any order on these pieces here is fine. It'll all give you the same function. I'm going to stop sharing for just a second to see if anybody else is trying to get in. Nope, nothing in the chat. Okay. Questions for me so far? Okay, let's keep going. So on our next function, same idea. Lead coefficient, I'll put in front, and then I'll fill in my x-intercepts in those parentheses with x. So I would have here for number 2, f of x equals 17. That's my lead coefficient, so that goes in front. Again, kind of with the line leader. And then x minus -2, x minus 5, and x minus 12. And then just one thing to tidy up here, minus a negative, we want to clean up to a positive. So I have x plus 2 for that first, these are called factors, for that first factor.
I have a question.
Yeah, what's up?
If it was two positives, it would stay positive, right?
Like if you had x plus 2, that would just be x plus 2. Yeah.
Okay.
I'm writing subtraction in here because that's our default to get our signs to change the way that they need to for that function. So we're not actually going to see this as we're writing these, but if for some reason you did have this, yeah, that would just be plus. Okay. Any other questions so far? Okay. Number 3, same idea. Why don't you guys go ahead and give this one a shot, and then we'll kind of touch base, check our work here in just a minute. Give this one a try. Okay, so for number 3, f of x equals or y equals, our lead coefficient goes in front, so 0.025, and then x minus -5, x minus -4, x minus -1, x minus 0, x minus 2, and x minus 3. We got a big line there, but that's okay. I need to tidy up where I have double negatives in here. So this would be plus, and this would be plus, and this would be plus. I would have x plus 5, x plus 4, and x plus 1. You can leave this x minus 0. That's fine. There's nothing wrong with that. A lot of times you'll see this cleaned up. So if I'm giving you the function, you won't see x minus 0 or x plus 0. You'll just see x. And a lot of times the problem that you have, if there is an x-intercept at 0, you're just going to see x sort of right next to whatever that lead coefficient is. So you might see this same problem written like this.
I had a question.
Yeah.
So were you saying that you could still leave that x minus 0 out of the problem as long as you put that x with the leading coefficient, or could you just leave that one out of the equation just as is?
So you can leave this as is.
Okay.
Both of these are correct.
Okay. Thank you.
Does that make sense? So you can leave this?
Yeah.
Okay.
Okay.
What I want you to be aware of, though, is that if I'm giving you the function, you're not writing it, but I gave it to you, and I said, what are the x-intercepts from this thing? It would probably look like this. But this and this mean exactly the same thing. Does that make sense?
Yeah.
Perfect. Okay. And again, I'm not super picky, so I would take this if you're writing a function for me, and I would take this. Or we had one up here where we left just the x, but like kind of in the middle. That's where it was when we wrote our function in the first place. All of those are fine. There's one more sort of description type problem where we're going to write a function here. I want you to notice that this time we've got the same x-intercept listed twice. kind of weird. The video you guys have for tonight for homework is going to talk more about problems like this and how we represent them and what those x-intercepts look like on the graph. For right now, we're just going to sort of dip our toe in the water with that and take a look at what that function is going to look like. So I'm going to start off the same way. F of x equals, our lead coefficient is -1, so I'm going to put that in front there. And then I would have x minus 1, and it's listed again, so I'm going to do another x minus 1. Now, this is fine. So if you gave me this, I don't have a problem with that. But I do want you to know that if I were giving you the function, what you would likely see is something a little bit different. So remember when we have the same thing that we're multiplying together, there's another way that we could represent that. So let's say I had 3 times 3. I could represent that as 3 squared. I can use an exponent to represent that repeated multiplication. I'm multiplying this thing by itself a couple of times. So this we could also write as f of x equals -1 times x minus 1 squared. Since I've got 2 of them, I don't have to write them separately. I could just use a square to represent that. Okay. Again, your homework, your video for tonight will go into this idea a little bit more. I just wanted you to sort of see that before you saw it for the first time in that video. Questions for me so far? Okay. So let's take a look at our last couple of problems here. The next two, number 5 and number 6, we're looking at a graph. So instead of being told the x-intercepts, we're going to pick them out of our graph. We're still being told our lead coefficient right on top of that graph here, but we do need to pick out our x-intercepts. So if I take a look at number 5, I have an x-intercept at -2, I have an x-intercept at 0, and I have an x-intercept at +2. So I'm going to use this the same way I used my x-intercepts up here, okay? F of x equals my lead coefficient, so that would be 2. And then I would have x minus -2, x minus 0, and x minus 2, +2. You do need to clean this part up where I have minus and negative. We need to rewrite that as a positive. But again, that x minus 0 is fine. If you were going through this and you just wrote x, that's fine. If you put your x right after the 2, that's also fine. They all mean the same thing. For this problem, I'm just going to leave that x minus 0. For number 6, same idea. They gave me my lead coefficient. I'm going to pick out my x-intercepts and write my function. So I've got an x-intercept at -2, at -1, and at +2. So my function would be, remember, start with that lead coefficient. F of x equals -2. And then x minus -2. I'm going to go ahead and switch that to a positive right now. X minus -1. And again, I need to switch that minus the negative to a positive. And then x minus 2. And that's my function for number 6. Questions for me? Okay. So yeah, what's up?
So how do you know which one is the leading coefficient?
Because they're telling me.
Oh, okay. I didn't see that. Okay. That makes a lot more sense.
Okay. Just like in our problems up here, it started with the leading coefficient is. It was just on top of our graph for these.
Okay, thank you.
We will have problems that we'll see later on where your leading coefficient may not be given. And if that's the case, your directions will say assume a leading coefficient of 1, unless you are specifically told otherwise or given information that makes you think otherwise. Anything else? Okay, the last thing I want to take a look at for today is a little quick review of the end behavior stuff that we saw the other day. I felt like we were a little bit rushed last time, so I want to take a minute to talk a little bit more about the end behavior stuff that we saw. So remember, for end behavior, the big idea was that I didn't actually have to have the graph to be able to decide the end behavior. If I do have the graph, like we do for number 5, really fast. If I do have the graph like we have for number 5 or number 6, I can look at the direction that the edges of the graph goes. What kind of arrow would I put? Well, this end's going down, so I'm going to put a down arrow. This end's going up, so I'm going to put an arrow pointing up. And that's telling me my end behavior. So remember, we always had that sort of default setting for our end behavior. And it kind of looked like, for the left side of the graph, it looks like as x approaches negative infinity, y approaches something. And then for the right side, it was really similar. As x approaches, this time positive infinity, y approaches something. And it was that something that we filled in every time. And what we filled in was based on the directions that our arrows pointed. If our arrow was pointing down, like we are here, if our arrow points down, that means we're going to fill in negative infinity. So on the left side of my graph, when x is negative, I remember because I look at it saying x is going to negative, and this is where the x values are negative on the left side. So since the arrow on this side is pointing down, that means I would fill in negative infinity here. Right? Going down means for that y value, that y-axis, I'm getting more and more negative. On the other side of my graph, right, when x is getting to be bigger and bigger positive numbers, my arrow's pointing up for this graph. If I'm pointing up, that means we're going towards positive infinity. Okay, so that was the big idea. If your arrow points up, you're going to fill in infinity. If your arrow points down, you're going to fill in negative infinity. If I have the function, we can figure this out as well, because this sort of general shape of the graph, I can decide based on the degree of a function and its leading coefficient. So if we hop back up here to number 1, I've got for my function, this is not standard form. Remember, standard form, we just look at the biggest exponent. This is not standard form because I would have to multiply, distribute all these things out. So when we don't have standard form, we find our degree by adding up the exponents for x. If I don't see an exponent, it's a 1. So I've got all 1s here. So my degree here would be 1, 2, 3. And our lead coefficient is negative. Based on just those 2 pieces of information, I can also decide my end behavior. So hopefully you remember last time me saying if the degree is odd, the ends go opposite. I think I said it about 75 times in the, I don't know, 20 minutes that we worked on this stuff. But if the degree is odd, the ends are going to go in opposite directions. Odd, opposite, okay? Just like here, our ends went in opposite directions, okay? 1, 2, 3, also degree of 3, also odd, okay? So if the degree is odd, we're going to go in opposite directions. So it's going to be kind of like a line. I just have to decide if the slope is going to be positive or negative. I decide that by looking at that lead coefficient. So my ends are going to go in opposite directions, and since the lead coefficient's negative, that means it's going to be a general downward trend from left to right, kind of like a line with negative slope. Weird stuff's going to happen in the middle, lots of potentially ups and downs like what we have here, but the general trend for the ends will be down from left to right. This end on the left side is going to go up, and this end on the right side is going to go down. Okay? So just from these pieces of information, I know what that end behavior is going to be. If we hop down to number 7, that's kind of what they're asking us to draw on here. So would you expect the function graphed below to have a positive or a negative lead coefficient, and why? So they've given us the graph, but no information about the lead coefficient, okay? So we're going to rely on its end behavior to make that decision. So this edge of the graph, I would want to put an arrow pointing down because it's going to keep going down this way. Other edge of the graph on the right side, I'm going to put another arrow going down because that's where my graph would continue going. Both my ends are going in the same direction, okay? Odds go opposite. So I know since these aren't going opposite, my degree has to be even. I'm just going to make that note off to the side. Degree is even. Odds go opposite. These are not opposite, so it has to be an even degree function. For even degrees, we took these notes the other day. Back here for just a second. For even degree polynomials, I know the ends go in the same direction. Ends go in the same direction. I decide if they're going up or down based on that lead coefficient. If the lead coefficient is positive, both my ends go up. If the lead coefficient is negative, both those ends are going to go down. Since both our ends are going down, that means our lead coefficient must be negative. Okay? So that's what this is asking. Would you expect this to have a negative leading coefficient? Why or not? Or why not? I would expect the lead coefficient, I'm going to abbreviate that word, to be negative because both ends of the graph are, we'll say, heading down. Or we'll say heading to negative infinity. How about that? That's a little mathier, a little more precise. So I decided that this had to be an even degree function because the ends go in the same direction. Since they're both pointing down, remember the transformations of functions that you guys worked on in Algebra 1. If I have a line with a positive slope and I change the lead coefficient to negative, that line would have a negative slope. If I have a parabola with a positive lead coefficient, it's going to open up. If I change it to negative, it's going to flip and open down. So this would be that option with that negative leading coefficient. Questions for me? The goal as we continue to work will be to take these new pieces of information that we learn about functions and their graphs, these new key features that we're able to talk about. We're going to keep sort of gathering them all together and then be able to use them together to give a comprehensive idea of what the graph of this function looks like. And so what we'll be able to do at some point is just based on the function that I have, be able to say, here's where I expect there to be x-intercepts, here's what the end behavior should be, here's where I have y-intercepts, here's where I would expect these different things to be happening for this function, or vice versa. If I have just the graph, well, these are the x-intercepts, so I know my function could look like this, and because the end behavior is this, I know that the lead coefficient should be positive or should be negative. Your homework video for tonight is going to talk about the sort of different options that we actually have for x-intercepts. So if I have an x-intercept that looks like this, here's how I would represent that in the function. So we're just sort of kind of squirreling away all these little pieces of information that we can get about a function, either based on its equation or based on its graph, and how those two things work together and how they represent this. Okay. Those are all the problems that we're going to go through together. So here's what I want you to work on for the rest of our class time. Your homework for tonight has a video that goes over what's called multiplicity of x-intercepts. So what you're going to see is that x-intercepts can actually look a little bit different. And we have a way to represent that in our function. And we have a, if I know the function, I have a way to know sort of what the graph's going to do at that x-intercept. So your video is going to go through the notes on pages 22 and 23. Okay. So you'll take notes along with your video for tonight. It's posted in the classwork tab. It's listed as an assignment for you guys, but the video itself is available in Delta Math, and you should see it assigned to you there. I believe it's called polynomial X-Intercepts, something like that. So video for homework along with your notes on pages 22 and 23. Again, the video is in Delta Math, so you have to go to Delta Math to watch it. The other thing I want you guys to work on with your class time today, or as homework, depending on how much you're able to get done in class, are the problems on pages 16 and 17 in your packet. So it's some review of some work that we've done. There are a couple questions that ask you about even and odd functions, like these two last vocab ones. Don't worry about even and odd. That was in some of the material that we skipped over that we're not going to worry about for this year. But the other stuff, perform the indicated operations, adding, subtracting, multiplying polynomials, you guys know how to do that. There's some problems in here that are going to ask you about degree and end behavior. You know how to do those. So work on the review problems on 16 and 17 as sort of a refresher as we're using all this stuff together. And then the last thing that I want you guys to use your class time for, so make this your first priority, are your Khan and Delta assignments. You have one assignment on Khan Academy and one assignment on Delta Math. Your assignment on Khan Academy is focused on this stuff. So if I have what's called factored form of a polynomial, what are the x-intercepts? Or if I have the graph, can you give me that function? And then your delta is going to focus a little bit more on that end behavior from a graph or from a function. But those are the two things I want you to make your first priority, okay? The Khan and the delta. I'm going to go ahead and stop recording now.